Okay, this lab is from your lab manual, Heat Effects and Calorimetry. It begins on page 97 of your lab manual. So page 97 is where your background information is. And 98, you would use that to answer your pre-lab. You're going to answer that and take a picture, scan it, however, and submit it. This lab goes along with chapter 5 because it's heat and chapter 5 is thermochemistry. So I'm going to follow the procedure on part A on page 99. We're only going to do part A. From the stockroom, obtain a calorimeter. A calorimeter is a device that measures heat flow. And for our calorimeter, we're going to use 2 styrofoam cups that are nested in each other. And I'm going to put my calorimeter in a large beaker just for stability, because y'all know styrofoam cups will turn over really easy. So that's just for stability. So we have that. I have the thermometer, a metal sample in my test tube. And it says a sample of unknown solid, but that's for part B, which we're not doing. Then the third paragraph says fill a 400 cubic centimeter beaker. That's another way of saying a 400 milliliter beaker, because a cubic centimeter is the same thing as a milliliter. And so I've filled up a beaker. I just used a 250 ml beaker with water, and that's boiling. While the water's heating, we're going to weigh our sample of the unknown metal. So as I do these masses, you guys need to be on page 101, because that's where you're going to record your data. And now I'm going to record the mass a little bit different than what the lab has. Do y'all see on page 101, the first 2 entries in the lab ask for it's the mass of the tube with the metal and then just the mass of the tube and the stopper. I'm just going to weigh the metal. So we're not going to have anything on those first 2 blanks. I'm not going to weigh the tube. So how I'm going to do that is I'm just going to put a small beaker on the balance and zero that out. I'm going to put all the metal in that beaker and I'm going to reweigh it. So that metal weighs 22.693 grams. So on the lab where it says mass of metal, 22.693 grams. Close that and zero it back out. Okay. The procedure is also going to tell us that I need to heat this metal for 10 minutes. So I'm going to heat it in the tube. Guys, what is the temperature of boiling water? It should be 100 degrees Celsius. If I leave that metal in there for 10 minutes, and we'll start a 10-minute timer, set timer for 10 minutes, then the metal should reach the same temperature. It said I can't. Oh, it said it can't set the timer. I just love that technology. The metal should reach the same temperature as the boiling water. Meanwhile, in following along with the procedure, the 4th paragraph says that while the water is boiling, weigh the calorimeter. So I'm not going to weigh it in the beaker. I'm just going to weigh styrofoam cups. So I'm going to zero out my balance. And I'm going to weigh my calorimeter. The mass of the calorimeter is 4.210 grams. So the mass of calorimeter is 4.210 grams. Then it tells me to put about 40 cubic centimeters, so that's 40 milliliters of water in the calorimeter. Now 40 milliliters of water, how much should that weigh? Because the density of water is 1 gram per mil. It should weigh about 40 grams. So I'm going to put 40 mils in here. And I didn't precisely measure 40, but that gives us, I'm going to zero the balance out again. Now, the water with the calorimeter is 43.416. So calorimeter and water, 43.416. And of course, I can subtract those and figure out the mass of the water. Now, I'm going to have my calorimeter in my beaker for stability. I'll zero the balance because you always want to leave the balance zeroed out. I'm going to measure the temperature of this water. It should be 100. But the temperature of this water, y'all, is the temperature of the metal. So I'm just gonna double check that. Because sometimes a thermometer, even though we know water boils at 100 degrees Celsius, depending on how that thermometer is calibrated, that thermometer might measure it as being 99 or 98 or 101 or whatever. So we're just gonna be sure. And when I'm measuring the temperature of the water, I want to be sure that I don't have my thermometer all the way at the bottom of the beaker, because it's going to be picking up some of the heat from the plate, which is way more than 100 degrees Celsius. Okay, it's holding steady right now. It's holding steady at 96. I'm going to leave it in there a few more seconds. The initial temperature of the metal is going to be 96.2 degrees Celsius. So on your sheet, initial temperature of the metal is 96.2. It says assume 100 degrees unless otherwise directed. I'm directing you differently. So the initial temperature is 96.2. Okay? I also want to measure the initial temperature of the water in my calorimeter, and this should be close to room temperature. My thermometer is still hot, and so I'm just going to let it cool down a little bit. And guys, these are alcohol thermometers. You don't shake those down, okay? You just let them. Y'all might not have ever seen that, because probably you've grown up with thermometers that are always digital, ear thermometers or forehead or whatever. But maybe some of y'all have seen an actual real mercury thermometer, and before somebody uses it, they'll shake it down. You don't have to do that with an alcohol thermometer. Okay, so this water ought to be close to room temperature, which is, it's kind of, y'all can't tell, but to me it's warm in here. So we're looking for like 20-something degrees Celsius. Okay, I'm still coming down a little. I'm at 25 degrees Celsius now. I'm going to make sure it's stable there before we record that. Let's come down a little bit, 24.8. Okay. It's the initial temperature of the water in the calorimeter is 24.5 degrees Celsius. So you see on your lab, initial temperature of water in the calorimeter is 24.5 degrees Celsius. Now, I'm not gonna sit here and just record this heating, but we're gonna let this continue heating. And so we're about to jump time. Okay, it's been heating plenty long. I'm going to take the metal carefully and quickly. I'm going to put the metal, just the metal, not the tube. I'm going to pour the metal into the calorimeter, and I'm going to measure the temperature that the water reaches. Obviously, the temperature of this water is going to go up. Why is it going to go up? This metal has a certain amount of heat in it. Heat, if you'll recall, the symbol is Q. So the metal contains a certain amount of Q. When we put the hot metal into the water that has a lower temperature, the metal is going to transfer its Q to the water. And when I put the hot metal into the water, the Q that's in the metal is going to be transferred to the water. That's the first law of thermodynamics. That's what's happening. The Q of the metal goes to the Q of the water. Okay? Same magnitude, same number, but the opposite sign, because the metal's giving it off, so that's negative, the water is absorbing it, so the water's Q is positive. When I measure the temperature of it, I've got a piece of cardboard that I'm going to use for my lid to try to keep all the heat in the calorimeter. So I'm going to quickly and carefully transfer hot metal into the calorimeter. I'm going to stir with my thermometer. How much do you think the temperature is going to go up? I always ask my students this. Okay? think about it. I want you to have a number in mind. Obviously, you're not telling us your number, but you'd be surprised. Water has a very high specific heat. It takes a lot of heat, a lot of Q for the temperature of water to increase. The highest temperature I reached is 28 degrees Celsius. Check and see if it's moving anymore. I'm kind of starting to back off of that. So 28 degrees Celsius. So the equilibrium temperature of the metal and the water in the calorimeter is 28 degrees Celsius. Okay? That is all the data you need for trial 1. Be careful when you're measuring your change in temperature. Change in temperature is always the final temperature minus the initial temperature. Both the metal and the water have the same final temperature, but they do not have the same initial temperature. In a way, with this calculation for calorimetry, you are using the formula that we discussed in lecture, that you also see in your pre-lab, Q equals ms delta T. You have two different systems you're looking at. You've got some information about the calorimeter. That's about the water. So it's when you do Q equals ms delta T, it's the mass of the water, the specific heat of the water, and the change in temperature of the water in the calorimeter. Your other system's about the metal. So the Q is the metal, the M is the mass of the metal, the S would be the specific heat of the metal, and the delta T is the change in temperature of the metal. Keep in mind, you do not know what the metal is, so you can't look up its specific heat. Ultimately, you're going to have to calculate that. Okay? Let us know if you have questions.